GPT-4 was supposed to be the peak for a while. We expected that we would spend years refining it before the next great leap. As it turns out, we were wrong. Because GPT-5 is here, and it isn't just faster or bigger. It's completely different. OpenAI have unveiled a whole new architecture and approach to artificial intelligence. It's the kind of different that makes you question where human intelligence ends and machine intelligence begins. On paper, GPT-5 is defined as a large multimodal transformer, which is just a fancy way of saying it can handle text, images, audio, and potentially even video all in one brain. This may not seem like a leap forward, because we were all used to generate image and even video from the same GPT interface. However, that form of multimodality was an illusion. Yes, it could read text and interpret images, but GPT-5 can do all of that, plus listen, speak, and even watch without switching models, which is the key difference. It's all in one brain, processing every kind of input you throw at it. Internally, this is powered by a unified embedding space, meaning all media types share the same representation layer, allowing context from an image to directly influence speech synthesis or code generation without any middle steps. In benchmark tests like MMMU, GPT-5 scored around 85% accuracy, a jump of nearly 20 points over GPT-4. This allows for seamless workflows where audio, vision, and text cooperate rather than work in isolation. This improvement means that, under the hood, GPT-5 is built on an evolved architecture that moves away from simply predicting the next word toward reasoning about what it's generating. Old GPT models, as well as most large language models available, work by predicting the most likely word that follows the one before, based on their training material. GPT-5 moves away from all of this by starting to approximate the process of thinking. What about performance and efficiency? Want to start with speed? Triple the inference rate of GPT-4 on the same hardware. Memory footprint? Reduced enough to run smaller, specialized instances for specific workflows. Latency is down to the point where interactions feel instant, almost like you're speaking to a person who never hesitates. Real-world tests show median response times under 250 milliseconds for standard prompts, compared to 800 to 1,000 milliseconds on GPT-4 for similar workloads. The reduced memory footprint means GPT-5 mini variants can now run in edge environments like enterprise servers or high-end consumer hardware without relying solely on API calls. And that speed isn't just for convenience. It's the beginning to chaining far more complex reasoning steps in real time. Instead of breaking down inputs by individual tasks, we can start working on more convoluted plans, requiring more than one step. In practice, this isn't just about raw speed. It's about where GPT-5 can live. That unlocks offline AI tools, privacy-compliant deployments in regulated industries, and on-device copilots that work instantly without sending sensitive data to the cloud, bringing the AI from the data center directly into your daily workflow. Persistent memory. The real paradigm shift is memory. If you followed my channel, we put a lot of weight on memory capabilities, as it is often the key to performance. Not just storing data, but also fetching the appropriate memory, processing it in the right way depending on the task, learning from it. Like we do. This opens up the possibility for genuinely personalized AI that improves over time, one that builds context and adapts to you without needing to be retrained from scratch. What about practical impact? What are some realistic use cases? For developers, it means you can walk GPT-5 through a complex API once, and it will recall every step the next time you return. For researchers, it can manage an evolving body of notes, instantly surfacing connections you didn't see before. For content creators, it can store brand guidelines, edit styles, and project histories, applying them automatically without prompts. These are some medium to advanced use cases. But what about tips for everyday users? Now more than ever, the trick to getting the most out of GPT-5 is not asking more questions. Rather, it's teaching it how to work with you. Start by saving prompts that give you good results. Build a library of best-performing workflows. Feed it examples of your style, whether it is emails, slides, documents, maybe that one novel you wrote. And don't be afraid to push its limits. It's designed to chain reasoning steps far deeper than GPT-4 could. Risks and trade-offs. Of course, more memory and deeper reasoning means greater risk. A misconfigured instance, or a conversation starting on a false premise, could carry forward bad information, bias, or even hallucinations from one conversation to the next. Even worse, as the model becomes more autonomous, it's harder to tell when it's using reasoning and when it's simply fabricating bad outputs with confidence because of a wrong assumption. Emerging research flags a grave risk. Agents with persistent memory unlock the potential for long-tail exploits. For example, Anthropic demonstrated that LLMs can carry dormant backdoors, behaving normally until a specific trigger activates malicious behavior despite passing typical safety checks. Similarly, recent security analyses of agentic AI highlight how memory poisoning attacks can subtly steer behavior over time, allowing an adversary to shift outcomes weeks or months later with little detection. In essence, when the model remembers malicious inputs indefinitely, it opens a stealthy attack vector that can only be discovered far downstream, making persistent memory both powerful and perilous. GPT-5 isn't just another upgrade in the AI arms race. It's a turning point. For the first time, we're talking about a general-purpose AI that feels less like a tool and more like a partner. One that can think faster than you, remember more than you, and keep evolving in the background. The real question isn't what GPT-5 can do. It's what happens when something this capable becomes the default interface for how humans work, learn, and communicate. Because once you've built an AI that never forgets and never sleeps, there's no going back.